This lesson covers virtual storage. For most virtual machines, you're going to want to create virtual hard disks, which are files on the file system of the host operating system, but that the virtual machines see as physical disks. They then go and create partitions on these disks, format them with a file system, and copy files including their own operating system. Windows Server 2012 introduces the VHDx format, which replaces the old VHD format found in previous versions. VHD had a limit of 2 terabytes, which limited when you can actually use a virtual hard disk file and may have had to instead use pass-through storage, which is where a virtual machine is directly mapped to a physical disk on the Hyper-V host. This is very undesirable as it breaks a number of virtualization features. The goal of virtualization is to break those bonds, break the bond between the virtual machine and the physical hardware in the host. When you use pass-through storage, that's a direct link. Technologies such as live migration, Hyper-V replica, snapshots cannot work when you use pass-through storage. Fortunately, VHDx now has a 64 terabyte maximum size, and I've never actually seen any clients with an NTFS volume anywhere close to that size, which means the need for pass-through storage really has gone. Additionally, from a performance perspective, VHDx gives you pretty much the same performance as a bare metal drive. So again, there's no need to use that pass-through storage. I can create new virtual hard disk files by the new hard disk option. And we can still use the legacy VHD format if we want. However, this is only be something you'd want to use if you needed compatibility with Windows Server 2008 R2 or Windows Server 2008. If you're all Windows Server 2012, you should always use the VHDx format. There are 3 different types of virtual hard disks to create, and for VHDx the default is actually dynamic, whereas if I select VHD, the default is fixed. The reason is there were not just maximum file size changes in VHDx, its whole engine on how it writes data was made far more efficient, which is why now dynamic VHDx is the default format. The differences are this: a fixed size virtual hard disk file allocates all of the space on the disk at the time of that disk's creation. For example, if I go to PowerShell, and I'm going to create a new fixed-sized VHD, 1 GB in size. So that's a fixed-size VHD. If I look at that on the file system, I'll see it's a gigabyte in size. It's allocated all of that space up front. A dynamic VHD grows as data is written to it. So initially it creates a very, very small file, but then as data is written, that file grows dynamically. So I'm going to create one of those. Notice I'm using the -dynamic switch with the same size. Now it's created a dynamic disk. And now I see that same disk, but look how small it is. It's now 4 megabytes instead of a gigabyte. But as data is written to that, it will actually grow. And this is why dynamic wasn't preferred in the VHD days. Those dynamic disks, because they had to grow as data was written, incurred a higher write penalty. But with VHDx, that really has been improved. There is also another consideration. In a production environment, a fixed-size disk allocates all the space up front, so you know you're not going to run out of disk space on the physical disks that file is using. If I create a lot of dynamic disks and I'm not monitoring the actual physical disk space usage, as those dynamic disks grow, there is the possibility the physical disk would run out of space, which would cause you a problem. So there are some production environments that don't use dynamic disks not because of performance, but because of concerns of actually running out of disk space. I also have the option to create a differencing disk. The goal of a differencing disk is I have a master image, a VHDx file. For example, this could be a Windows 8 client image. I then want to create 100 virtual machines all running Windows 8 that will have a small amount of difference. With a differencing disk, I create a child VHD of that parent, that master image, that reads the data from that parent, but any writes go into the differencing disk. So it's saving you a lot of redundant disk space. If I had 100 VHDs all containing Windows 8, a huge amount of that would be the same content. When I use a differencing disk, then it's only saving the changes to that separate VHD file. So here I create that by passing a parent path to the parent, the path for the differencing disk, I'm telling it it's differencing, but this would happen implicitly anyway, and then a size. So now I also have a differencing disk that's linked to here. And I can remove them as well, using the remove item. So this is not VHD specific, this is just the same as doing a delete, a remove item, deleting a file. It's actually possible to natively mount VHDs in Windows Server 2012. For example, I could just double click on one of these and it would actually go ahead and mount this straight away. I could then initialize it and format. I can also do that via the mount VHD command. So VHD and VHDx is native to Windows Server 2012. I can mount them, dismount them, just like any other drive in the host operating system. So it's just nice to know how easily you can interact with those VHD files. Once I have VHD files, there may be some options you need to perform in terms of their ongoing maintenance. For example, I can edit a disk. I can specify a particular VHD or VHDx file. There is no difference in terms of these functionalities. So I'll select a dynamic disk, for example. I can say I want to compact it, i.e. maybe I wrote a lot of data and then deleted a lot of data. It can shrink it back down. I can convert it to, for example, a fixed size. I can expand it, make it bigger. So I can convert between VHD to VHDx, VHDx to VHD, fixed to dynamic, and it's actually going to copy the data between them. So I have these ongoing maintenance capabilities available to me. For the virtual machines themselves, I'm going to jump back to my host again. We have two different types of bus. I have the IDE bus. Now, Hyper-V requires the virtual machines to boot from the IDE bus because this is really an emulated type of bus. It's not synthetic. So the operating system, the boot, and the system drives must connect to the IDE bus. And there are two IDE controllers. Each can have up to 2 devices. So really I could connect 4 VHDs to the IDE controller. I also have the SCSI controller. So this is synthetics. This is going to get the highest performance. So all your data drives, application data, you want to connect via the SCSI controller. The great thing about the SCSI controller is I can actually hot add disks to the controller while the VM is running. So I don't have to shut it down. I can just add additional disks to the SCSI controller while it's running. I cannot do this to the IDE controller. I should point out, to do those conversions between VHD types, between fixed and dynamic, those expansion, you do have to shut down the VM. You cannot do it while that VM is actually running. This concludes the lesson on Hyper-V storage.